Hello everyone and welcome to this new problem, first one for me in applied math, and we are required in this problem to calculate the angle between two planes, alpha and beta. Let's assume a couple of random planes. So let's say that this is alpha, and somewhere we have beta, right? 3D planes floating in space, and yeah, I'm restricting their graph, since at some point we need to limit their extension, but you already know that planes are by definition infinitely large. They extend forever and ever. They don't have finite limits, but in our graphs we need to restrict them somehow. So they intersect. Let's say that they intersect in this area right here. Okay, they intersect. So they create an angle between them. Let's say that the angle is theta. Okay, theta. So how do we calculate the angle? Well, so far we only know a formula involving angles, and that is the one related to the dot product. So the angle between two vectors is given by the following formula. So cosine of the angle equals, let's say that the vectors are A and B, so cosine of the angle is the absolute value of the dot product if we want to find the smaller angle between two arrows, although that's a different discussion that we can address at the end of the problem, divided by the length of each vector. Okay, how is this formula related to our problem? In our problem we have planes, so is there any relationship? That's the key to the problem, since there is a vector that characterizes each and every plane. That vector is the normal vector. So let's say that this is normal vector n alpha, meaning that it's perpendicular to alpha, making 90 degrees to alpha. Alpha, by the way, let me remove here, it's a little bit confusing, the label. This is plane alpha and the other one is plane beta. And there is another vector, normal vector, to plane beta and beta, also perpendicular to the plane it defines. Well, don't you think that the angle between alpha and beta, the blue angle between planes, must be the same as the angle defined between their normal vectors? And of course it's the same. In some ways it's like taking both planes, alpha and beta, and rotating them, both of them, 90 degrees. Okay, and doing that they would still create the same angle in between. So that's essentially what's happening when considering their normal vectors. It's like rotating them 90 degrees, and therefore the angle between the vectors is still theta. So now it's a matter of finding those normal vectors and then using them in the formula placed on the top right corner of the slide. So given alpha x plus 2y equals 3 minus z, let's move all the coefficients to the left. So x plus 2y plus z minus 3 equals 0. And for beta, initially it's 2x plus 3z equals y, becomes 2x minus y plus 3z equals 0. And side note, bottom left corner, given a plane, so given ax plus by plus cz plus d equals 0, assuming a 3D plane, although you know that all principles apply to n dimensions, basic geometric principles. So given this plane, this is a 3D plane with normal vector, the coefficients in order. So normal vector components ABC. Okay. That means that the normal vector to alpha using the components would be 1, 2 coefficients on the left, and 1. Similarly, the normal vector to beta would be 2, -1, 3. Okay. Now insert them in the previous formula in blue and calculate the angle. So now cosine theta equals the absolute value of dot product. Well, I'll write the formula first. N alpha dot n beta divided by the length, the modulus of n alpha times the length of n beta. So this is the absolute value of 1, 2, 1 dotted with 2, -1, 3 divided by the length of the first vector, square root of 1 squared plus 2 squared plus 1 squared, all of the components squared, add them all up, times square root of second vector, components 2 squared plus -1 squared plus 3 squared. So we have absolute value of the dot product component by component, 1 times 2, 2, second component times second component, -2, third component times third component, plus 3, divided below square root of 2 squared 4 plus 1 plus 1 root 6 times 3 squared is 9 plus 1 10 14. Okay, so plus 2 and -2 they cancel out, so we obtain absolute value of 3 is just 3 divided root of 84. 14 times 6 is 84. That's not the end of the problem, since this would be just the cosine. So theta equals the arc cosine of 3 over root 84, which is close to 71 degrees.